Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today we'll be looking at a CAPE integrated mathematics question, all right, which is Module 2 of the syllabus, and that is statistics. And the topic that I'll be focusing on today is standard deviation. Okay? Now here we have our question. It says two machines A and B are used to pack biscuits. A sample of 10 packets is taken from each machine and the weight of each packet, measured to the nearest gram, is recorded. The results are shown in the table below. Calculate the standard deviation of the weights of the packets taken in the sample from each machine and comment on the results. Okay? So that is our question. Now, before I actually start the question, let me first remind you about the standard deviation formula for raw data. All right. It says S is equal to the summation. So what is the summation? You know that we're adding, all right, we're adding the X minus X bar all squared values. All right. The X bar that you see there is just referred to as the arithmetic mean. Okay. And we're dividing that by N minus 1. Okay? And in case you don't remember what the arithmetic mean formula says, it says X bar is equal to the summation of X. So you're summing all the X values and dividing by N. Okay? Now, the standard deviation formula that I gave you right there is just one formula. All right? That's just one formula there. But there are other formulas that you can also use to calculate the standard deviation for raw data. Okay? I'm just only using one of them. Okay. So let us now start the question. We have our solution. All right. So we're basically going to compare the standard deviation for machine A and the standard deviation for machine B. Okay. So first, I'm going to find the standard deviation for machine A. All right. So I'm now focusing on machine A. So let me just scroll down a bit just to get a bit more space. Okay. So we're focusing on machine A. So machine A. Okay. All right. So we're now going to find the arithmetic mean for machine A. All right. So that's X bar. All right. That's the arithmetic mean for machine A. All right. I have a subscript capital A there to show that I'm calculating the arithmetic mean for machine A. And that is equal to the summation of all the X values. So all I'm going to do here is just add all the values in the first row of the table. All right, that's for machine A. So I'm adding 196 plus 198 plus 198 plus 199 plus 200 plus 200 plus 201 plus 201 plus 202 plus 205. Okay, so those are all the values in the table, all right? And we're going to divide that by n. So n is the number of values that you have there in the first row, all right? And that is what? 10 values. So we're dividing by 10. N is 10. Okay, so X bar, all right? So the arithmetic mean for machine A is equal to, now if you sum all the values in the numerator, you're supposed to get 2,000. Okay, 2,000, and I'm dividing by 10. Okay, I'm dividing by 10, that's n. And that is equal to, when you divide 2,000 by 10, you're supposed to get 200. All right, 200. Good. So remember the unit now, we're dealing with the units here, and the unit that was given in the question is grams. So we have 200 grams. Okay, good. So now that we have that, let us now formulate a table in order to calculate the standard deviation for machine A. Now let's look back at the formula above. All right, now in the formula, you realize that I have X bar. All right, I just calculated X bar a while ago for machine A, so we're good there. But we need to find X minus X bar. In other words, we're going to have these values in the first row, all right, minus the arithmetic mean that we just calculated a while ago, all right? And we're also going to have those values squared, okay? So let us now construct the table. So in my first column, I'm going to have X, all right? I'm gonna have all the X values, and the X values are 196, 198, 198, 199, 200, 200, 201. All right, we're gonna have 201 again. We're gonna have 201 again, and then we're going to have 202 and then 205. All right, so that is what I will have there. Good. Let me just draw a line so that we can separate it from the other values that we're gonna have to the right. All right, good. So in my other column now, in the formula, remember, I have X minus X bar. All right, so I'm going to calculate the values of X minus X bar. Okay, so we know what X bar is, which is 200. All right, so all we have to do is just subtract now. So 196 minus 200. All right, that's going to be -4. 198 minus 200, that's going to be -2. -2 again. 199 minus 200, that's going to be a -2. Sorry, that's going to be a -1. All right, a -1. And then we're going to have 200 minus 200, which of course is 0. All right, let me scroll down a bit. All right, then 200 minus 200 again, 0. 201 minus 200, all right, that's going to be 1. 1 again. 202 minus 200, that's going to be 2. 205 minus 200, that's going to be 5. Okay, so those are our values. Good. Now let me draw another line to separate this from the other values that are to come at the right. All right, good. So let me scroll up now. Okay, good. And remember, in the formula, we also have X minus X bar squared. So X minus X bar all squared. Okay, so all I'm doing is just squaring the values here in the second column of the table. So that's -4 squared, which is 16. -2 squared, that's going to be 4. -2 squared again, 4. -1 squared, 1. 0 squared, 0. 0 squared again, 0. 1 squared, 1. 1 squared again, 1. All right, let's scroll down. All right, so that's 1. Then we're going to have 2 squared, which is 4, and 5 squared, 25. Okay, so those are my values in the table. Good. So just going to draw some lines here just to make it a bit neater. All right. Okay, good. So we are now on track. All right. So if you look in the table now, all right, we want to find the summation of X. So we're going to add these values. Okay. We already know that the summation of X, we know that the summation of X is going to be 2,000, right? We had calculated that already. And now we need to find the summation of x minus x bar, all right? And we have the summation of x minus x bar, all right? We don't really need this, but you could calculate it, all right? You could calculate it if you want, but we don't really need it. So that's -4 minus 2 minus 2 minus 1 plus 1 plus 1 plus 2 plus 5, and that will give us 0, okay? And we can add the summation of x minus x bar squared, okay? And if you add these values, 16 plus 4 plus 4 plus 1 plus 1 plus 1 plus 4 plus 25, you will get 56, okay? Good. So let's now calculate the standard deviation here to the side. So let me do it here. All right, let's do it here to the side. All right. So we know that x bar is equal to 200 grams. I calculated that. All right. Now we need to find the standard deviation. So the standard deviation is going to be, all right, the summation of x minus x bar, all right, squaring that. We're going to square that. Oh, I almost forgot that in the standard deviation formula, we also need to put a square root. All right, we need to also put a square root. So let's do that. I apologize. All right, we also need to put a square root here. All right, square root. Good. So that is our formula. That's the summation of x minus x bar squared divided by, all right, we're gonna divide that now by n minus 1, all right, and we're gonna have the square root of that, okay, so the square root of that. So let's calculate it now. That's the standard deviation of A. So the standard deviation of A is going to be the summation of x minus x bar squared, which we had calculated that to be 56. All right, so 56 divided by n, which we know is 10 minus 1. All right, 10 minus 1. And remember now that we also need to take the square root of this value. Okay, we need to take the square root of that value there. So the standard deviation of A is going to be, that's going to be, if you put this answer into your calculator, all right, we will get what? So that's the square root of 56 divided by 10 minus 1, which is 2.494438, all right, 8258. Those are all the values in my calculator. But remember now that in your Cape Integrated Mathematics examination, at the front of the exam booklet, it states that if your numerical answer is not exact, you should write it correct to 3 significant figures. All right? So what will that be in 3 significant figures? That's going to be 2.49, all right? And that's 3 significant, all right? 3 significant figures, okay? 3 significant figures. Good. So that is it. So that is our standard deviation for machine A. We now need to find the standard deviation for machine B. So let us now do that down here. All right. So we need the x values. All right. So this is for machine B. Machine B. So we need to have the x values. All right. And the x values in the second row were 192. All right, 194. The others were 195. All right, 198. Then we have 200. Then 201, 203. All right, 204. Let me scroll down a bit. All right, 204. Then we had 206. Then 207. All right, those were our values. Now, what else do we need to also calculate? We also need to calculate x minus x bar. Okay, so let me first draw a line just to separate it. All right, just to separate. That's x minus x bar. All right, so let us first calculate x bar over here. All right, so that's x bar for machine B. That's the arithmetic mean for machine B. All right, if you add all the x values, you will get 2000. All right, you will get 2000 when you add all the x values. And we're going to divide that by n, which we already know is 10. All right, so the standard deviation for machine B is also 200 grams. All right, so let us now calculate x minus x bar. That's 192 minus 200. All right, that's negative 8. 194 minus 200, that's negative 6. 195 minus 200, that's going to be negative 5. All right, 198 minus 200, that's negative 2. 200 minus 200, that's 0. 201 minus 200, that's 1. 203 minus 200, that's 3. 204 minus 200, that's 4. 206 minus 200, that's 6. 207 minus 200, that is 7. Okay, that is 7. Now, what else do we need to also calculate? All right, what else do we need to also calculate? We also need to calculate these values squared. All right, that's x minus x bar squared. Let's do that. So let me draw a line. Okay, good. So now we need to calculate x minus x bar squared. Okay, that is what I need now. Good. So let us now calculate x minus x bar squared. That's negative 8 squared, which is 64. Negative 6 squared, 36. Negative 5 squared, 25. Negative 2 squared, that's 4. 0 squared, 0. 1 squared, 1. 3 squared, that's 9. 4 squared, that's 16. 6 squared, that's 36. 7 squared, that is 49. Okay, good. That is 49. So what can we do here now? All right, we're now going to do some addition now. All right, we're going to do some addition of these values. Okay, let's do some addition now. Okay, good. All right. So we know that the summation of all the x values is 2000. All right. You don't necessarily need to calculate the x minus x bar values, but let's just do it. All right, that's x minus x bar. All right, that's going to be what now? Negative 8 minus 6, minus 5, minus 2, plus 1, all right, plus 3, plus 4, plus 6, plus 7. And that will give you 0, all right, 0. X minus x bar squared, if you calculate these values, 64 plus 36 plus 25 plus 4 plus 0 plus 1 plus 9 plus 16 plus 36 plus 49, all right, that's the summation of x minus x bar squared. If you sum all those values, you will get 240. Okay, 240. Good. So let us now calculate the standard deviation for machine B. All right, standard deviation for machine B. That is equal to what? That is going to be equal to, remember now in the numerator we have the summation, all right, the summation of x minus x bar squared, all right, x minus x bar squared divided by n minus 1, all right, and we also have to take the square root of this value. Okay, so the square root of that value. All right, so the standard deviation for machine B is going to be equal to, all right, so the summation of x minus x bar squared that we had calculated from the table is 240, all right, divided by n minus 1, which we know is going to be what? That's going to be 10 minus 1. All right, 10 minus 1. And remember now that we need to take the square root of this value here. So the square root of that value. All right, now if you put this in your calculator, the square root of 240. All right, let's do that. The square root of 240 divided by 10 minus 1. All right, I will get 5.1639777795. All right, now remember now that we need to write this value correct to 3 significant figures. That is what you're required to do in the exam. So to 3 significant figures, all right, that will be what? 5.16. All right, that will be the 3 significant figures. So 3 significant figures. Okay, good. Let's now scroll back up at the question. Let's look back at the question. The question says, calculate the standard deviation. All right, so calculate the standard deviation, all right, of the weights of the packets, all right, taken in the sample from each machine, all right, from each machine. We have just calculated that, right? We have calculated the standard deviation for machine A and the standard deviation for machine B. And the last part says we are to comment on the results, all right? So we're to do some interpretation here. Okay, so what I'm going to do is just to draw a number line, all right? I'm going to draw a number line and then we're going to do some discussion, okay? We're going to do some discussion. Make it long enough. Good. So for the number line in the middle, I have what? 0. All right. Then I will have a -1, -2. All right. -3, -4, -5, -6, -7, and -8. All right. To the right of 0, I will have 1, 2, 3, 4, 5, all right, 6, 7, and 8. Okay, Now let us look at it. Let us now look at the values. For machine A, all right, this was the table that we got for machine A. If you look in the second column here, all right, you realize that the values are from -4 to +5. All right, I hope you see that. We have the values from -4 to +5. So let's just represent that on our number line. All right, let's represent that on our number line. I'm gonna do it in blue. So -4. All right, we're gonna be at -4. And we're going up to +5. That's somewhere here. All right, good. That's -4 to +5. And we're now going to draw a line to represent that interval there. Okay, good. Now, x minus x bar is what we call the deviation. All right, the deviation. So the deviation for machine A ranges from -4 to 5. So I'm going to write here. All right, I'm going to write here now. Then we'll do it in a different color. Deviation of machine A. All right, that's the deviation of machine A. Good. Let us now look back at the table for machine B. In the second column, the deviation for machine B, right, x minus x bar, that ranges from -8 to a +7. So let us now represent that on our number line below. So we're doing that in blue. So that's -8, somewhere there, to +7, that's down here. All right, somewhere there. Good. Now let us draw our line to represent that interval there. All right, so that's -8 to 7. All right, good. So this is now the deviation. I'm gonna write it here, the deviation of machine B. Okay, now let us compare the deviations. Okay, let us compare the deviations of machine A and machine B. Now, we can say that machine A has a better standard deviation because the deviation of machine A is less than the deviation of machine B. Okay, so whenever the deviation of one is less than the other, it can be said that that one is the better standard deviation. Okay, now that is our final statement. Let's do that here in black. So machine A, this is my statement. Machine A has a better standard deviation. All right, it has a better standard deviation because, all right, because the deviation of machine A, all right, of machine A is less than, that's that symbol, is less than the deviation, all right, is less than the deviation of machine B, all right? It is less than the deviation of machine B. Good, and that is our comment. All right, so in this question, we have calculated the standard deviation, all right? The standard deviation using raw data, and we have commented on the results. Now, these are typical typical questions, that they can ask in the CAPE examination for you. So please ensure to take notes. All right? If this video was helpful for you, please ensure to like this video, subscribe to the channel, and also comment down below. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. I thank you for joining.